Uh, so welcome back to the Unity workshop. This will be part 2 of the workshop. Get started. Please scan the attendance carefully here. Okay. Has anyone not scanned the QR code yet? If not, let's get started with this week's content. So last week we have set up our Unity editor, as well as we've gone through a very simple script to control the player moving in our 2D platform. So what we'll be going through this week is the asset store, level creation, as well as some basic interaction and some UI components that you can add into the game, into your game. Yeah. So we last left off here last week, which is a very, very bearable, very bearable implementation of the video game. In case if you forgot about it, so basically we have a player that can move around and can jump platform. But the platform itself and the player probably doesn't look very interesting, since it's just white. It's just a white circle and a white rectangle. So it's not very interesting. So we should probably work with something more interesting other than just these kinds of placeholder art assets. And at this point, you would say, but I'm not an artist. I don't know how to draw. And this is where Unity as a store comes in handy. So you can open any of your browser. And just type in Unity as a store, and this will show up. So the Unity Asset Store is basically a repository of free and paid assets that is ready for development. All assets that you obtain through this asset store can be used to publish games, but they might be subject to some end user license agreement. The assets that you've bought, whether they are free or paid, they will be synced to your Unity ID. So this is the ID that you have used to obtain like a free personal account, as well as you register your Unity Hub with. So let's move in back to the asset store. If you loaded this website, you can see that the number here corresponds to the number of available assets for each category that has been listed here. As you can see, there are 55,000 plus assets for 3D and somewhere roughly around 40,000 assets for 2D. And all of these assets, they could be art assets, they could be any kind of programming related assets, algorithms assets, and stuff like that. So let's just click on one category so you can see it. So we're going to look at 2D. And there's camera plugins, it's these kinds of asset packs, PCG kits, as well as video effects, skill effects, stuff like that. So there's a lot of stuff that you can get. Most of them are paid, but they're free assets as well. If you feel like any of these paid assets is suitable for your use case and you really want to go in as an indie developer or an individual, a solo developer, and then look no further here, it can potentially help you reduce a lot of your development time. But today, I'm obviously not going to tell you to buy an asset. We're going to look for a free asset, and then I looked for one for you guys already. So you're going to search for 2D platformer. And, so, yeah, if you look for 2D platformer, there's this simple 2D platformer asset pack that's free. So we're going to be using this asset pack for the rest of this workshop. I'll close the link. And once you have gone to this page, you can click Add to My Assets. And it will prompt you to sign in. And once you've signed in, you will be able to get the asset pack. Since I've already gotten the asset pack, I will be signing in here. So, since I've already gotten the asset pack, I will be signing in here. But this is the asset pack that we'll be using. So once you have added the asset pack to your account, you just need to go back to the Unity editor, click on Window, Package Manager. And the Package Manager in Unity allows you to add different types of packages, including programming and scripting API packages that Unity has. For example, there are just a lot of advanced stuff that is not included in the base engine that is part of Unity's extensions that you can get here. We won't be going through any of this because these are quite advanced already and it's not suitable for this workshop. What you want to do is to click on this packages part here and click on My Assets. So these are the assets that you have in your Unity ID that you have obtained through the Unity Assets Store. As you can see, I have quite a lot of things here, but you just want to look up for a simple 2D platformer assets pack, and then click on Import. So this will import the asset pack into your current Unity project, and if this prompt comes up, just click on Install Upgrade. So this will install the asset pack, and this comes up to you, and you just need to import all of it to the current project. So click on Import again. And once all of this is done, you can go back to your project part, and you should see this folder called Simple 2D Platformer BE2 show up under your assets folder. So far, do we have any questions? If you have any questions, please send them in the Zoom chat so I can read and respond to it as soon as possible. So once you have added this asset pack, let's see what's provided in this asset pack. So we have a bunch of coins here. If you go into the Simple 2D Platformer in the Sprites folder, you see there are lots of coins here. And there's also some tiles, an enemy, and a player. So the player already has all these like animation frames that's already done for us, but we won't be touching that today. Animations would be next week. There's also a demo stage, which we will be touching as well. But most importantly, all of these art assets are available for us to use. So obviously, you can start building your level now by removing the ground and start dragging in the sprites to the game one by one and then try to line them up properly. But as you could have already imagined, that this would be a very lengthy process, and it would be very difficult for you to line up everything pixel perfect. So instead, what we are going to do is to use one of Unity's built-in tool, which we call TileMap. Essentially, this tool allows you to paint each sprite asset into the world, as if you're trying to draw something. Let me show you how it's done. So first of all, you need to add a tile map to your game scene. So you right click the hierarchy, go to the objects, tile map, and we're going to select a rectangular tile map. It probably should have been easier called as four-sided, but rectangular tile map. So once you've done the tile map, once you've added the tile map, this appears in hierarchy, and you will see that the tile map would have this lit up grid that shows up in the editor scene now. This is how you know the tile map is active. Then you want to click on Open Tile Palette that shows up when you select the tile map in the editor scene. Once you're in this tile palette, you can see that there is a tile map, but it says no valid palette. It says a default brush and flood fill, alt Z position. What do all these means? It's not very, very important. But what you want to do now is you want to click on no valid palette and select create new palette. This allows us to create a new set of sprites which we want to put into the tile palette to be used as assets to be painted on. So click on create new palette and it will ask you what we want. How are these? We will just keep everything as normal and change the name.
Grid. There's nothing visual to tell us what the cube is or how we should feel about it. But if we have the cube deal damage in an area around itself and then disappear.
All right. Okay, so you want to click on create palette. We're going to keep everything normal. Then for the name, we will change it to ground. And click on create. So this brings up the window folder selector. And we're going to go back 2 folders to assets. Click on new folder. So I'm creating a new folder for you. It's glitching a bit. So create new palette. And let's rename one of the new folders that I've just created to home. Open it up and select that folder. Here. So now we have the tile palettes folder, and we have this one palette, which is ground. But right now, there's nothing in this palette. So what we want to do is to add sprites that we have here into the palette. And we can do so just by clicking on platforms and dragging it into the tile palette. So this opens up this other folder again, this folder picker again. But we're not going to change the position because all it does is to split every single tile into its corresponding sprite. So we're going to keep this in the same sprites folder here. Okay, hangs out a bit, and as you can see, it creates every single tile as its own sprite, as its own like tile material here. So, but now you can see that we have all of these cubes that we can pick from. And as we select one of these cubes, we can hover over the editor, the scene editor, and you will see that it shows up here. And as we left click, we will be able to place it directly in the mode. And you can do it as if it is actually a brush. Click and drag and drop that. And select different tiles by clicking on the top palette on the right. And there are also several different other tools, such as paint a fill box, like this. Or you can use a flood fill with active brush. You can also erase, pick one brush, and move the entire section. The move is only for at least this side here. You select with the select tool, and then you can move it around like this. So you're also able to select multiple tiles at once and then paint them in as if they're one single entity. Okay, so this is the tile palette, and it does help us create levels much quicker, as you can already tell, since we don't need to drag and drop everything in. We just need to paint them on as if I'm doing some kind of painting, which is much easier to work with. So let's save the level. And now, if we try to play it right now, you will realize that it still falls over. And this is because as we add the tile map, we also need to reattach the colliders onto the tile map. But instead of attaching like a box collider, because if we attach a box collider now, it's just going to find the leftmost, topmost, like the diagonals of this tile map, and then attach the entire collider here. If I play now, you will see that my player gets launched now. Actually, it did not. Let's have a try. So, okay, I think this is not very good. But you can see that the collider is actually not fitting. So let's remove the collider. Oh, okay, I know why. I attached the wrong collider. Oops. It should be box collider 2D, not box collider. Now you should see the player gets launched. Okay, so you see that the player actually stops on top of the tile map. This is not a desired effect. So instead, what we are going to do, we're going to remove the collider. And we're going to add a different type of collider called the tile map collider. What a tile map collider does is it's going to match the geometry of the tile map and then put the colliders directly on top of it. So as I select it, you will see that green lines appear in between the tiles because every tile will be its own collider. So as I press play now, you will see that my player stops on one platform as intended. Okay. The problem with this is that this may cause some kind of no, actually I'm not going to go through that first. So now we solved this already. What about we also put a new sprite for our player? So we're just gonna go to our player and you can swap out the sprite by changing the sprite selection here in the sprite renderer component. So as you click on it, you can type in idle 0 idle, and you would see our player's idle animation here. Just click on it, and now the player would be like this. As we've changed the sprite, a circle collider might not be the perfect fit. So a general rule of thumb when selecting which colliders to use is to ensure that the collider has a perfect fit with the visual representation of an object. In this case, the player itself looks more squarish than circlish. So we're going to remove the circle collider and add a box collider to the instead. But note that because the sprite is tinier than an actual unit in Unity, it doesn't fit as well. The collider is the green line here, and we are the visual representation is inside. So we want to make it fit, and what we can do is to go scroll down to the box collider to the component. Click on Edit Collider. Now you will see 4 dots show up here, which you can then drag and drop until this fits the visual representation of the player's sprite. Once you're done, you just need to click away, and the collider will be fully fit. So now we have a player, and we have a perfect tile. What's the worst that could happen? Okay, my player just flipped over like that. So obviously we don't want this to happen in like a platformer game, as the player probably should not be able to flip over. Oh, it did a 360 there. So the reason that the player did a 360 sometimes is because the physics system in Unity sorts of accumulate the friction force that is being applied onto the player. And at certain point, one of the tile maps and tile map between the tile map and tile map collider, between the tiles, there is a very, very small gap in which the player gets stuck in. and then it flips over. So there are two components to it. One is the friction, and two is the tile map tripping the player over. So usually what we want to do to fix this is to go to the tile map and click on Add Component, and we're going to add a composite collider. This will make sure that all of these tiles be merged into a single large collider, such that whatever that's in the middle does not trap the player. And before this, you also need to click on Use by Composite on the tile map collider, such that now this becomes one large unit. And as we are falling down, so now this becomes a one large unit, and we should, okay. So the thing about adding a composite collider is that it will also automatically add a rigid body to the component. And you cannot remove this because the composite collider requires it. So we're just going to change this body type back to static so that this is not affected by gravity. Now that we have this, we should stop seeing our player tripping over when we're moving normally. It seems to be working. Usually it should have tripped over by now. So the second thing is as our player falls down, now since that it actually has directions and faces, as our player fall down, you'll see that it actually rotates, right? So this might not be be a good way to play the game. You probably don't want the player to flip around on its belly when it moves around. So we can add a constraint to the player's rigid body. So we will select the player and go to rigid body 2D component, and we can freeze its rotation. This means that on the player's own accord, if there are no external forces from other objects in the scene, the player will not rotate on its z-axis, which means it will not rotate around in this 2D world. So I will just click on play here to show you what this means. Now, regardless of how I stand on the edge of the platform, I do not trip over. Okay, pretty good. And the final thing is, you'll realize that now the jump doesn't work anymore. And this is because we did not attach a ground layer to our tile map. So we're going to select the tile map and add the ground layer back to our tile map. And by doing so, there's something wrong with the raycast, which we need to change the values. Let's go to the scripts. Let's change the raycast value. So we probably need to increase this to like 0.5. So every time you change a sprite, you probably need to recheck all of its behavior. Okay, pretty good. So now we have regained all of our functionalities, and we also get a very easy way to design a new level. So you might be asking, okay, we now have, a new level. What can we do with this, right? There should be a way to end the game. That's one of the objectives of playing a platformer game, is that there should be an end to the level. So coincidentally, there is a flag called finish that is provided through the asset pack. We can just drag and drop the flag somewhere here, and then put the player back down. This means that ideally what we want to achieve is, as the player hit the flag, we will be able to let it end the game. But as you have already know now, the flag is not that convenient, and we still need to program out bit by bit. So in order to do that, first of all, the flag itself will also need to have a hitbox. So it needs to have a collider of its own. So for this case, we will just use a box collider 2D. And then adjust the collider such that it fits the flag's sprite. And after we add this collider, we also need a way for the player to know that it has collided into a flag. And this is where another system in Unity comes in handy, and is what we call tags. Different from a layer that we have learned last week, tag is not made for physics interaction, and it's meant for interactions between different types of game objects that does not require any kind of physics separation. And as such, each game object can only have one tag, but they can have multiple layers. So in order to add a tag, we just click on the object that you want to add a tag with, and go to the inspector and select tag, and you'll be able to see that there are several different types of tags that is already available. So these are predetermined tags, and the more frequently used tags that the Unity team has decided that developers would use. And we're gonna just use one of these right away, and we're gonna select on the finish. So once we do that, the finish flag would have the finish tag on it. But still, we have not programmed anything yet. So the player would not be able to know that there is a finish line there. Show you what I mean by that. Let me just try to. It's 5 still not. It's 5 still not strong enough. It's fine. Okay, I'm just gonna drag and drop like this. As you can see, my player will hit the flag, but it will not be able to do anything. It's just a break. So we still need to implement the physics, or rather the interaction, in which what the player will be able to do once it hits the flag. So we are going to go back to our scripts folder and create a new C# script in which we can. So a general rule of thumb is you want to separate the different types of behaviors even for the same game object, such that it is easier for you to expand on its function, on its behavior or its functionalities. This is why we are separating the movement and the interaction script. So now you would click on the interaction script, and you will see that this is here. And we're just going to remove all of this because none of these are important. What we're going to do, what we're going to use is what we call a on collision enter 2D. And it takes in a collision 2D as its argument. What this does is that when a game object that has this collision enter 2D method attached to it collides into any game object, when it collides into any game object, this method will be called by the game engine. And anything that is defined as a behavior will appear here. Show you what I mean by this. I'm just going to add a very simple debug.log here called collided. And we're going to go back to the editor. So since it triggers on every single collision, this means that as I hit the ground, okay, I forgot to attach that to the player. So let's attach this to the player first. So this means that as I hit the ground, I will see the collider being fired. As you can see from here, the number goes up as I hit the ground. And the same thing can be said as I hit the flag. Yes, so this means we just need to be able to gather that the game object that we have collided into is a finished flag. So what we're going to do is we're going to use this argument. This argument passes in the object that we have, passes in the collision 2D, the collision details of the object that we have collided into. So what we can do is to check if this object that we have collided into has the tag finish that we have just attached to. So we're going to say if collision.gameObject, it's in a string, is equal to finish. Now we're going to say level. So as I collide into the flag, I will see level complete show up. This works even if I'm just touching it like this. That's cool. So we still need a way to actually transition to a new level. And this is where something called Scene Manager comes in handy. So a Scene Manager is a class in the Unity engine that handles the transition between different game scenes. So this is a game scene, and everything else that we add into as a scene will be a new scene as well. So as you can see, this scene is called sample scene, and we can create multiple different scenes just by adding it to the assets folder. So we're gonna go to the assets scenes folder and right click create a scene. And let's add this as end scene. So once I've added a scene, I can double click on it to open this scene up. And this will be the base scene, which has absolutely nothing but just the camera. So in order to kind of show that this is something different, I'm gonna just add a capsule object. Scene. So I'll go back to the sample scene. And as you can see from the second point of the slide, it says that all scenes to be loaded are required to be in the build settings. So Unity does not know what scene to load if the scene is not provided as part of the build's configuration, even if the scene itself is available inside of the scenes folder. So in order to add it to the build settings, we're just going to click on the ribbon File, Build Settings, and as you can see here, there's scenes/sample scenes that's already in the build. I'm just going to drag and drop the end scene to this part here, and this shows up with an index of 1. Once I've added that, I'll go back to my script, and we're going to add this line, Scene Manager dot load scene. So we can load it with a name, in which case this is called end scene. So this means that as I collide on the fact, I should see me going into the end scene. And this works. Additionally, if you have several different levels and you just want it to transition to the next level, what you can do is to load the next scene with this following code. So we're going to get the active scene, and we're going to get the build index of the active scene and do +1. So what this does is it's going to get the index of the active scene and load the one that is one index ahead of it. In our case, this would be sample scene as index 0 and end scene as index 1. So if we use this line of code, it should behave similarly. Yes. So that's good. All right. We have a way to end the game, sort of. But that is probably not enough. That's probably not very challenging. Are there any other kinds of aspects that you can think of that that a platformer game should have, aside from a starting point and an ending point. Let's have a very quick session Q&A in the chat. If anyone knows the answer, please type them out, or you just want to simply guess an answer. While you are thinking the answer to that question, if you have not scanned the attendance QR code yet, this is a perfect time to do so. So what are some other aspects to a 2D platformer game, other than just the starting point and the ending point in terms of level design? Points. Okay, yes, we need some ways to get points. Maybe some form of rewards. Yeah, that sounds good. Anything else? Anything else other than points that you can think of? Environment, obstacles, yeah, obstacles, enemies, checkpoints. Okay, good. So you guys have the great gist of things. Achievements, that is a bit too ambitious. Time limit, dialogue. Dialogue might not be a very strong requirement, but time limit might be if you're trying to make a speedrunning game. Okay, I think we have enough of opinions here. So, suggestions. Yeah, we have enough of suggestions here. So let's go one by one. So as Daryl first mentioned, we're going to need some points, some way to incentivize the player to explore around the stage to get more points. And maybe they would be able to do something with the points, I don't know. So it feels like the stars that you normally see in Mario games or something. There are points in Mario games as well. So what we're going to do is we're going to go back to the sprites in the asset pack that we've downloaded. And there is a coin. So we're just going to use the gold coin here. It's easier to work with one than to work with 3 different types of coins. So we're just going to add a gold coin in. And as you have already guessed, this does not work out of the bat. We still need to program it. So what we want to achieve is that as the player moves into the gold coin gets collected, and we get some extra points for this. So first of all, the coin needs to be collectible. And in order to do that, it still needs to detect collision. And therefore, add a circle collider to this. And then we're going to edit the collider such that it's a bit smaller and that it fits the coin's shape in general. So once we've done that, since this is a collider, it actually means that as I move through as a player, I get stumped on it. We probably don't want this to happen because this means as I collect the coin, my momentum will be clear. And so I will not be able to quickly collect the coin and jump away. So this will not be possible, right? So what we're going to do is we're going to change this collider to a trigger collider by clicking on this is trigger checkbox. And by doing so, I open up this possibility that the player will be able to run through it without losing any momentum. And this is the effect that we're looking for. So it's here, yes, and they're a bit different from each other as well. As to the events that they trigger is different. So remember that we have just wrote on collision enter 2D just now. But the on collision enter 2D method will not be invoked if the player moves through a trigger collider. Instead, what we are going to need is the on trigger enter 2D, which takes in a collider 2D as the argument. So here, I'm going to once again demonstrate that this works by adding a debug statement. So I'm going to click on play. And as I move through the coin, I want to see that trigger is being printed out in the console. Obviously works now. So in most cases, you might want to have several different types of interactable items in the level. So it's not just going to be one trigger collider. And as such, we are still going to need to add a custom tag to the coin so that we know that we're triggering a coin. So we're going to select the coin and click on tag, then click on add tag that allows us to add a custom tag. So in this tags thing here, I'm just going to click on add and give it a tag name. And I'm going to call this coins with an X, coins. Save it, and again, we need to go back to coin object and apply the tag. Similarly to what we did to a layer. So as I save it, now that the gold object has a tag of coin. So what we're going to do next is we're going to add this to the code. So if collision.compare tag, if collision.gameObject compare tag is equal to coins, debug.log coins collected. So we probably also want to have a system to calculate the player's current score or how many coins they have collected. So for simplicity's sake, I'm just going to add this to the player interaction script. It's probably not the best idea, but it works. So we're going to use it. Since the number of coins that we collect is most likely going to be an integer, so we're going to save the score as an integer, whole number. I'm just going to name it score. So then, as I collect a coin, I want my score to be increased by 1, which we can use the plus operator. If you want it to be increased by a custom value, you can use the plus equal operator, which basically means that the score will be added by 1 and then reassigned to the score value. So in this case, I'm just gonna do plus equals 50. So every coin that I collect increases my score by 50. And I'm going to print out the score. So I'm going to print out the score plus the score, and this will print out the score as well as the number that is stored inside the score. So let's get back here. And since the coin is already attached, the player already has this attached. I click on play here. And now, as I keep going through the coin, you can see that my score is increasing by 50 every time. But this is not a good idea, as you know, the coin should be collected once and then it should be gone. You don't want the player to be able to keep going through it and just keep racking up points through it. So finally, what we're going to do after we have added our score, I'm going to destroy game object of the game object of the object that we have collided into. In this case, it would be the coin. So now, as I move into the coin, we get our score increased by 50, and we also see the coin being destroyed. So it will no longer appear in the game scene until we refresh the stage. And this works exactly as how we have imagined it to be. Cool. So at this point, you would say, now let's add more coins then, such that it is, well, possible for the players to get more points than just 50 a single stage. But you also come into the realization that to configure each coin, you need to manually pull in the sprite, add a collider, and edit the size of the collider and move it around and give it a tag. That is very troublesome. We don't do that in Unity. Instead, we are going to use a Unity tool or a feature that we call prefab. Yes, we're going to use prefab. So what a prefab is that it allows us to reuse the game objects that has the same properties and components attached to it, except for the transform field, which means we will be able to reuse game objects that have the same collider sizes, the same scripts attached to it, the different types of animations attached to it, just in a different position inside of the game scene. And as you could have already imagined, this is going to make things a lot faster for you when you compare it to manually pulling things one by one over and over again. And most importantly, if in any point of time during your development, you decided that this particular game object requires a new behavior attached to it, you only need to edit the prefab instance, and all of the objects that you have placed in all the scenes in the project will be updated with this new behavior. So let me show you how it's done. So let's also maintain a good folder structure. We're going to go into Assets folder, right click, create folder, and name it prefab. with an S, prefabs. You're going to double click the folder to open it. The way to make a prefab is very simple. All you need to do is to go in the hierarchy, select one of the game object that you want to make a prefab into, and drag and drop into the assets folder. And now you have made a prefab. And you will notice that the gold coin now has a blue icon on it as well as a blue name. So this indicates that this is a prefab instance. For any changes that I made to the prefab that is on the transform component, I will be able to do so. If I selected an instance inside of the game scene that was a prefab, and I add a new component to it. So just for fun, I'm just going to add a new box collider to this. You'll notice that a blue line show up right next to it. And now this new line shows up here, which says it's prefabs and there is an override. So what this blue line signifies is that this prefab is not the same as the template that it was created from. It contains additional or it is modified from the original instance, which you can apply this override to the original prefab or revert it back to its original state without this modified behaviors. So we're going to revert this. Similarly, if what we have selected is a prefab, this shows up here as gold prefab asset. If I add any component to the prefab itself, like this box collider, if I go to any instance of the prefab inside of my game scene, you'll see that the box collider is also added to it. And if I remove this, it's also gone. So this makes it very easy for you to add new stuff, new behavior to a prefab. And if you need to reuse a particular game object with the same behavior across multiple instances, a prefab is the easiest way to go about doing it. So now, with this prefab, I will be able to add more coins to our level. Like this. And all of them works the same. Just to demo that I am not pulling on your leg. 1 coin, 50. 2 coins, 100. And they get destroyed. 3 coins, 150. 4 coins, 200. So yes, as you could have already tell, this is going to make level design so much simpler for you. That's what they say anyways. So we have our coin, we have our finish line, and the second thing that Daryl and Junwon also mentioned is obstacles. We need some form of obstacles that will force the player to do movement inputs such as jumping, to avoid them and to increase the difficulty of the game. So how do we go on doing this? Is that let's get back to where we were in the sprites folder, and do you see the spike sprite here? So again, we're just gonna pull the sprite in here. So as you have again already imagined, this doesn't work out of the box. We need to program the behavior into this spike. So let's set some expectations. As I move into the spike will kill me and the level will restart with all the coins back to its original position, and my score becomes 0. With this expectation in mind, we first need to set up the collision for the spike such that I will be able to step on it and that the engine knows that I have collided into it. So as the spike is a triangle here, we are going to use a polygon collider. And as you can see that the lines are not specifically straight because it doesn't meet up at the top there. And this, as I mentioned, you want to make sure that your colliders or hitboxes are as accurate to its visual representation of the game object. So I'm just going to click on this collider geometry, edit, and since this is a polygon collider, I will be able to add more sides to it, but this is not important. The important part is I want to bring this vertex up. So I'm just going to go to this vertex, select it, and drag and drop it. I think this looks okay. So once we're done, let's save this. So now the spike has a good collider. We still need to implement the logic in which it dies. And very similarly to how we would do the finish line, we first add a tag to it, in which case I'm going to add the respawn tag to it that is already available, part of the engine. Then I'm going to go to our script, and here we're just going to add a new if else statement that if collision dot game object is equal to respawn of die, and scene manager scene if scene dot build index. So what this does is it loads this current active scene again. This is going to reload it to its original state of the scene. So let's show you how it's done. So we're going to press play here. And as I walk into the spike, you can see that the game restarts and I get teleported back. To show you that I am not trolling, I'm going to pick up a few points. And then, as you can see, my score is 50, 100, the 2 coins that are gone. If I step on the spike, the coins are back. And if I collect 1 coin, you can see that it says 50. So uncollapse the sequence. This means that my score is also reset. And this is because when the scene starts from scratch, it basically just means that everything resets to its original state that the scene was originally in. This is a good thing for us. And similarly to how we have done the coins, since you probably won't have just one spike in the scene or in any level, you can make the spike a prefab as well. Now we have made the spike a prefab, and I can put it anywhere, and it's going to have the same tags, and it's going to have the same behavior. Okay, so far, do we have any questions? No? No questions? Okay, so if you have any questions at any time, please make sure you type them in the chat so that I can see it. Okay, so now that we have a very simple level, the final thing that we need is let's try to move the score indicator so that the player would be able to see it in the game view. So in order to do that, first of all, we need to set the aspect ratio of the scene view, the game view, to a fixed aspect ratio. Previously, we were using free aspect. This means that as I drag this through, okay, where do we get the game assets? You can get it here. After you have get it, you will be able to download it or import it by going to Window, Package Manager, and go to My Assets and click on Import for the single 2D asset pack. Okay. So we are going to set this to a set aspect ratio, which in this case we're going to select 16:9. Or you can also set it to a set resolution, like Full HD. Drag the scale down a bit. So when it comes to the UI or user interface, the most important thing is we need something called a canvas. Not to be confused with the Canvas website that you're using to submit your assignments. The canvas we're saying here is more akin to a drawing canvas. This is what Unity system does. So it draws the UI on as if it's on a canvas. So we're just gonna right click here and then go down to UI, and we will be able to create a canvas. But if you don't want to do that, you can just create any of these UI components and a canvas will be automatically created. So I'm just going to click on Text Mesh Pro. You will definitely see this pop up. And just import the essentials, because if you don't do that, the text doesn't show up. Once you're done, we don't need the examples. Just import the essentials, and that's good enough. And we can close the window. So once you've done that, you probably would have noticed that this new text appears at the very bottom left of your screen. This is exactly the effect that we want to have. And now you will see that the canvas itself is actually very large. So we were here with the player. The canvas is here. And in order to see the canvas properly, you'll want to double click on it so that it zooms all the way out to the size of the canvas. And the player game scene that we have is here. So this is because in all technicalities, the canvas and the scene exist in different spaces. So they're rendered differently. But let's not go into the technicalities. Just know that the canvas is not part of your board. So it exists as a completely separate piece of 2D space that you will be able to edit separately. So in the canvas, everything works the same. You'll move your text around, like how you would by selecting it and using the move tool. Let's move the score text to the top right, maybe. And we will be able to change the text in it. For example, I can change it to be like score 1000. This gives us the freedom to move it around so that we will be able to see where it is, where the boundary is. This might be too small for some people, so you will also be able to adjust the font size by changing it here. Let's put this to 50. And you'll notice that this wraps our text around, and we don't want that. So what you can do is to change the width of the text object. Okay. And then move it out again. You'll also be able to change things like the font style, bold it, italicize it, underline it, strike through, change the cases. I don't think that. Or change the color of the text. I think sticking it to white is good contrast with the background. Changing the alignments. So it's like this. Change the as well. And a bunch of different functions that you can try to explore it yourself. So I'm not gonna go through all of them. Most importantly, we can change the text content, and we can do it through code as well. So what we're going to do here is, first of all, in our interaction script, we are going to need a reference to this text object that we have in the scene, so that we will be able to modify it. And the way to do so is you can use a public variable, as we have done here in the movement, to add the jump speed and speed variable. We're going to use a public field, and we're going to use TMP text. And we're going to do score text. Score text. So as I do this, I go back to the editor. If I click on player and go down to its player interaction script, you see that this shows up. And I will be able to drag and drop this TMP text object into it. And I will also be able to rename the TMP text just in case. So now I go back to there. You can see that this is now attached. So once this is attached, I will be able to also change the text of it. So we have a score plus equals 50. What I'm going to do here is to change the text of the UI. So I'm going to do score text.text equals score plus score. What this does is this makes our score text to be the same as this format. And because of that, we will probably also need to be able to reset the score to 0 as the game has just started. So we're going to add a start function to this. It sets the score to 0 and sets our score text to 0. So what this does is, as I click play now, I would see the score reset to 0. And as I pick up any of the coins, the score increases. And as I die, the score resets to 0 again. So this is pretty synonymous to what we have done, what the interaction has been so far. It's just that now player will be able to see it on their own screen, and they don't need the console to look at what their current score is. Yeah. Okay, so yeah, that is pretty good. And since we have some additional time here, let's move on to some other stuff. I think someone mentioned enemies. We can do enemies as well. I think might be able to. Let's like do a quick poll here. Cannot do a poll. Oh, I can. Okay. So, what feature would you like to see? Uh, Enemies, time, time limit, or a timer, maybe. I think checkpoints would be a bit difficult to implement in half an hour. Yeah, checkpoints would be a bit difficult, so we're just gonna go with one of two choices. So enemies or time limit. Save. This. So let's do a quick poll, and I'm just going to implement the feature that the most people choose. I'll close the poll in another 30 seconds. So if you haven't voted, please vote. Five, four, three, two, one. Okay. So um, I guess we're doing enemies now. To be a bit rushed in half an hour, so if you cannot follow, I guess you can still watch the recording. Okay, so let's get started now. So if we go back to our sprites here, you should see that there is an enemy sprite. So I'm gonna open this up, and we're just gonna select any enemy style sprite. I'm just gonna use ID 0. So let's put this somewhere. So I'm just gonna. So what are the expectations of an enemy? What are the expectations of an enemy? Any guesses? Yes. It does damage to the player. Since we don't actually have a HP system, I don't think we will be able to do damage. Okay, and move around, yes. Move around. Yeah, I don't think doing damage is a good expectation if in what we have created up until now. But that's a good guess. Anything else? move to the player would be a bit difficult because we don't have a very sophisticated AI system for 2D games in Unity yet. But yeah, if it's in like a top-down game or in a 3D game, sure, it should move to the player since there's more access there. Think about what the enemies do in Super Mario. It moves around. What else does it do? Any other guesses so far? So minus 856. Walk in a pattern. Okay, okay. Walks in a pattern. Sort of, yeah. We will be able to implement something similar, but not very advanced. Okay, so let's set some expectations here. The enemy should move around, yes. And let's say it should turn over when it hits a wall or it hits a spike. So it will only move within a very constrained set of area. Okay, then say we have some form of so if the enemy hits the player will be able to the player will just die and you will respawn, something similar to this. And if we have time to do this, we will also be able to implement a system whereby if the player jumps on top of an enemy and it falls down directly, the enemy dies. So there are three expectations that we are looking here. And I think the third one would be a bit difficult to implement within half an hour, but if we have additional time for this, we can do that. So let's start simple. First of all, if the player hits the enemy, the player will die. So similarly, first of all, it still needs to have collision detection. So we're going to add a box collider and make sure that the collider itself is in its perfect representation here. And then we also want this thing here to have a tag of respawn. This means if the player walks into it, the player dies. Right now, as the enemy doesn't move yet, we just walk into it and you can see it up. Good. Secondly, this thing should move. So to do that, we're going to go into the script and add a new C# script we're going to call enemy movement. I did not just name it movement. I'm going to open this and name it enemy movement. Sure. Yeah, this is why I hate you. Yeah, just gonna create a new script. Just add to this one. Ah, what? Let me just use this one. Just relaunch Visual Studio. Yes, it does. Yes, that does. Let me just put it in another folder. Actually, I'm just gonna name it differently. So waste any time here. I'm gonna call it enemy behavior here instead. Okay, apparently it still doesn't work. So settings. This So the problem is, right, if you rename it inside of the Unity editor, it sometimes doesn't work. So make sure you don't do that. It's the time. Back. Okay, there you go. Okay, sorry for the inconvenience. Yes. So uh, we are going to need to first of all again define a rigid body so that we'll be able to move the enemy better. So we're just going to put the rigid body 2D component onto the enemy. Then what we can do is again refer to this rigid body. And let's also define a speed for the enemy. And by doing so, let's start. Get the reference to the rigid body 2D component. The somewhere. So what I'm going to do is I'm going to define an integer called direction. So the direction is either 1 or -1. And every time as I collide into the wall, my direction changes from 1 to -1 or from -1 to 1. What I'm going to do here is that every frame, I'm going to set our velocity to be speed times direction. And the y component, we can keep it as is. It's usually not a huge problem. The enemy may fall off the ground, but that's fine as well. So once we've done that, this means that the enemy will move over and over again, since the update occurs every frame. And finally, as I enter a collision, I don't care what collision it enters. I'm just going to make the direction times a -1, which changes it between +1 and -1, and then reassign that. By using times equal to reassign this back. This means that as long as I bump into anything, it will make the enemy move left and right. So let me attach the player, the enemy, and then adjust the speed to be something faster. Move the player away from where I'll get hit as soon as possible. See that this is working. So I press play, we should see that the enemy move. So a very similar issue here is that because as it moves around, it collides with the ground again, and then it jitters between +1 and -1. So what we want to do is to check if the collision dot game object dot layer is not equals to a ground layer. Then we do this we times the direction. And similarly to the player, we're just going to do this. So if I go into here, then I can select what the ground layer is. So ground. And we're just going to see that now we should start looking. See what the is colliding. It's fine. Talman. It's fine. Talman. Talman is wrong. Yeah, this is game development 101. This is what's gonna happen during your week 5 game jam. Why is it still colliding with tower? I hate this layer system so much. Changed such a long time. Sometimes it just goes into something because shit. So the problem with the layer system is sometimes it bugs out and it just doesn't work properly. And in certain cases, we would have to hard code the value instead. Six. Thank you, Unity. Thank you for the part. But I digress. So this works. Okay, and again, you can see that the enemy was bouncing around just now, so we're just going to freeze the rotation so it doesn't bounce. So now that it worked, and the player dies, how much time do we have? We have 20 more minutes. Okay. So let's reiterate that this works. Let's just make sure. Yes, so it was colliding with the ground, and this thing here, right? Sometimes, not sometimes, most of the time, it doesn't work if you try to assign it to a layer mask. If that makes sense. Like, there's some kind of magic voodoo going on internally in the engine that bugs this out. Which is why usually you have to hard code the integer value of the layer, in which you will be able to obtain it through here. 6 ground. So you just have 6. So to reiterate that this works, get myself better. So the final thing is that let's make it such that we will be able to step onto this enemy and kill it. So there are several ways to do this, right? There are several ways to do this. And one of the ways that I think would be preferred for the difficulty of this workshop is we add a new collider to this. So we are first going to tag this with a separate tag. No, we're going to tag this the same, but we're going to add a new empty object as the child of this idol. And we're just going to call this head. So this is where our head of the enemy would be, and is where we will be able to step on in order to kill it. So we can assign a different tag to the child of the game object within this hierarchy. So here I'm going to add a new tag, and I'm going to call it enemy head. So as I call enemy head, I will be able to add some more stuff to this. And we need to be able to do collision detection as well. So what I'm going to do is add a box collider to on edit collider, and then move this to the very top half of our enemy here. And in order to make this not interfere with the original collider that we had, I'm gonna go to the original collider, click on edit, and then shrink this down below the trigger collider that we have. This gives this like a 100% sure that the collider works properly when we're trying to kill the enemy from top, and also move it away from the sides. It's unforgiving. Okay. So now we have the enemy hit, and the easiest way to do so is that we go over to our play interaction again. On trigger enter, if the game object is equal to enemy hit, say enemy kill, and then we add a score, hit the score, and then we deploy, and so aside from that, we probably also want to launch ourselves up. So, which in this case, what I'm going to do is in player interaction, I'll refer to player movement string, obtain the movement reference in start, which gives us the component movement that is currently attached to the player when the game is running. Go to player movement, and I'm going to abstract out this jump function. Here. So what this allows us to do is that as I step on it, I will be able to call player movement jump. And this allows us to step on the enemy, and as if we're bouncing off of the enemy, we jump once more time. So to show you that this works, I'm first going to change this speed to 0 so that it is possible for me to show you that it works without me having skill issue. Move this closer to the player and click on play. So as I jump on the enemy, that didn't work. We are going to need space. And we also will have to change this. Also, we'll have to change this to collision detection continuous. If now this should make it possible for us to step on it. So it's not supposed to call collision. Oh, okay, I think I know what's happening. So it's supposed to trigger, but since there is a second collider on this object here, it triggered that collider instead. So I believe what we need is to just create this empty. If I attach this instead. I Oh, I know why it's not working. Okay. Ignore what I did just now. I forgot to change this to be trigger collider. So if I don't change this to a trigger collider, this triggers the on collision and the event, which checks if the game object is of type respawn. And since this is attached to another game object, since it was attached to another game object, it actually chains it up to the root and checks that it's a respawn tag, and it respawns me. Yeah, okay. Now it should work. So the problem here is that, as you can see, as I step on it, what is being destroyed is the head object only, and not actually the enemy object. So what we are going to do is we're going to destroy game object dot parent transform. What this would do is that this is going to destroy the parent's game object. So collision dot transform dot parent dot game object. So this will get the head's parent object, game object, and destroy it, which will destroy the enemy in return. So that works. Now, in order to make this workshop, and assign a net value to this. So now, if I play through the game, I'm progressing smoothly. Yes. Okay. So I think we're done with that. That's some pretty simple with that. Just to recap what we did for the enemy is that first of all, we attach a collider to the enemy such that when it collides into anything, we change its movement direction by changing the direction. And for every frame, we're going to make this enemy move in its specified direction times speed. Then, in order to kill the enemy to jump off of it, we add a head. We add a head child object that has a different tag and has a different type of collider. So here we're using a trigger collider instead of a solid collider, a collision collider. So by doing so, it allows us to use two different types of comparison. And in this case, we are going to do a compare tag to the head, add a score, and destroy the parent of this head object, which is this enemy object here. And then finally, we're going to jump off of it. So this is a simple-ish way to implement this kind of mechanic. There are multiple ways to do that as well. You can use a ray cast like how we did for jumping, but with different values. You could probably work with some other ways of implementing collision detection systems as well. But yes, since we only have 3 minutes left, any questions? Please type them in the chat. If there are no questions, our weekly challenge for the week, just so you can be a bit more involved in the game. We will try to design a level. Can you please send out the file? It is too fast. I cannot follow typing. Yes, I can send the code excerpts into the Discord chat later. That will not be a problem. Okay, so the weekly challenge is for you to design a level or multiple, if you like to, and to implement a transition between them. And if you haven't already scanned the attendance QR code, this is it. It actually closes in 1 minute, so please be quick. And if you don't have any questions, thank you for coming, and I'll see you next week. Hopefully physical, but if not, I'll see you online. Thanks for coming, and you're free to leave if you don't have any questions.